The potential to accelerate the progress on the way we think about and use energy in the United States is huge. We now have about 4% of our electricity provided by wind and solar, but we have the potential in this country for much more.
Probably the most important social problem of our time is the transition to alternative energy sources. One of the topics we're interested in here at the university is how alternative transportation fuels will evolve in the U.S. over time. What are the competing sources? How will it play out? What kind of cars will people be driving in the future?
They've been bragging about it.
So we were thrilled to have the honor to host President Obama here at Argonne National Laboratory. He wanted to show support for transportation research as well as for that private-public partnership. Research is wonderful, but we are really geeked when that technology gets picked up and commercialized, put out in the field, and is benefiting society at large.
The Joint Center for Energy Storage Research, with the acronym Cesar, intends to transform two of our energy sectors. The transportation sector by electrifying automobiles, and the electricity sector by enabling the wide penetration of wind and solar renewable electricity. In order to do this, we need to have batteries that perform 5 times better than today's best commercial batteries and do it at 1/5 the cost. If you take the back of an envelope and a pencil, you can easily calculate, and the entire community agrees on this, that we can achieve a factor of 10 in energy density over the current commercial batteries. Technologies, especially in the energy sector, when they become mature, typically deliver half of the theoretical potential. So our goals of 555 are well within what science can allow and what technology can deliver.
So within the Center for Transportation Research, what our regime really is to develop unbiased data, scientifically sound information, technically correct, and then provide that out in the public domain so that you can really develop the appropriate policies, and it might feed into regulation as well. Everything from experimental, which might be trying to improve the efficiency from engines or total vehicles, or even incremental improvements in lubricants and surfaces, trying to reduce friction. So as you improve the efficiency, sometimes you have a trade-off with some emissions. We're studying a gasoline direct injected engine, so better fuel economy. And at that same time, we're looking at particulate matter characterization here, the particle number, the formation under various operating loads, to ensure that we're not compromising the environmental benefits at all.
As we ramp up with clean energy, as we roll out more and more of these solar panels, what happens on cloudy days like today? If the sun does not shine, they only produce a fraction of what they can potentially produce. And that's where our research comes in place. My center works on developing software tools to study key strategic energy issues. At this location and several other locations, we're collecting about 100 gigabytes per minute of data, and we're using Argonne's high-performance computing capabilities to store and process that information. The grid is a very interconnected and synchronized system, and supply and demand have to be in balance at all times. And so it's highly critical that we can get a real good forecast for how much power these panels produce over the next at least 24-hour period. And so the data will advance the art and science of solar forecasting.
Cesar will rely on the nanoscience discoveries of the last 10 to 15 years to enable it to first observe battery phenomena and materials at the atomic and molecular level, and second, and more importantly, control it so we can produce for batteries at the system level or the macroscopic level behavior that we can't achieve today.
What we're interested in is how do consumers react to all these abilities. So would you be willing to change the way you consume electricity? And if you do, by how much?
Most economists would tell you that the optimal policy for dealing with climate change is a carbon tax. But it's not going to be successful, in my view, unless other countries do follow similar policies. So a unilateral carbon tax for the United States is not going to have much impact on climate change, but it will have serious impact on economic activity and welfare in the United States.
Looking forward 20 years, question is, which assets should I build? Which technology should I invest in? Because we don't really know what the cost performance of those technologies are. So Argonne's developing these advanced tools that allow us to account for some of these uncertainties. We call them stochastic tools.
Recently, the EPA announced new corporate average fuel economy standards. So this is going to be a doubling of fuel economy from light-duty vehicles and trucks by 2025. So it's really a phenomenal rate of change. So that really does take everything from the incremental improvements that we've talked about to some of those revolutionary improvements as well.
The magnitude of challenge is huge, but there are many, many opportunities for groundbreaking and next generation research.